Hello viewers, this is Wagda Ronald taking you through the tutorial for A-level Mathematics paper 2, and today's video we are going to talk about questions on composition and resolution of forces. Now this topic is under mechanics and suitable for both senior 5 and senior 6 students. So these are the very questions I left in the previous video, and I believe by now you have already tried them out and ready to mark yourself and check your progress. Now we shall start with question 1, and question 1 says, in an equilateral triangle PQR, three forces of magnitude 5 newtons, 10 newtons and 8 newton act along the sides PQ, QR and PR respectively. Their forces are in the order of the letters. Know that word, order of the letters. Find the magnitude of the resultant force. So such questions in this form are easily done by sketching. So what we are going to do, we are going to first sketch an equilateral triangle PQR. Remember, an equilateral triangle, all sides are equal and the angles inside are each 60 degrees. So that when you add all the three angles, you'll be able to get the 180 degrees, which is the total interior angle sum of a triangle. Now that you have drawn out our equilateral triangle, next is to put the forces. Remember, they told us the forces are in the order of the letters, so meaning that 5 Newton force is in the direction of PQ. So we shall come here and on PQ we shall draw our 5 Newton force, which is that. Next is the 10 Newton force. 10 Newton force, we are told that's in the direction of QR, so we shall come at QR and draw our 10 Newton force. I think you can see it's in the direction of QR. Then lastly, 8 Newton force is in the direction of PR, so we shall come at PR and draw our 8 Newton force. I think you can see it in the direction from P to R. So basically we have shown all our forces on a diagram. Next is to answer the question. They wanted us to get the magnitude of the resultant force. So what we are going to do, we shall say let F be the resultant force. And now since F is the resultant force, next is to resolve both horizontally and vertically. So in that case we have resolved both horizontally. So the first line, so this shows the horizontal component and this one shows the vertical component for 5. For example, 5 is entirely horizontal, that's why you see here 5 and here 0. When you come to 10, 10 has a component or horizontal component to the left, meaning it will be negative. That's why you see here the negative sign there. So it is negative 10 cos 60 degrees, and the corresponding vertical component is upwards. That's why it is positive here, positive 10 sine 60. When you come to the 8, the horizontal component is to the right. That's why here it is positive 10 cos 60, and the vertical component is upwards. That's why it is still positive 8 sine 60. Now when I add 5 plus negative 10 cos 60 plus 8 cos 60, I'll come up with 4. And when I add 0 plus 10 sine 60 plus 8 sine 60 degrees, I come up with 15.5885. So now that I've resolved, next is to get the magnitude which they wanted. So I'll come and say that magnitude of the force will be equal to 4 squared plus 15.5885 squared, everything under root. And when I use a calculator, I'll come up with my magnitude as 16.0935 newtons. So basically that's what they wanted, and now let's see how marks can be awarded. So the first mark was for the resolving horizontal. So these marks, these 5, negative 10 cos 60 and 8 cos 60, that gives you the M1. Then the second mark, M1, was for resolving vertically, so this 0 and this will give you this M1. Now the B1 is for the output, adding this to get 4 and also adding this to get 15.5885 will give you that B1. Now the M1 is for this part, and B1 is, and A1 is for the final answer which they wanted. So basically that's how the 5 marks could come about in this question. So now we shall go to question 2, and question 2 came from UNEB 2017 per question 4, and it says, in a square ABCD, 3 forces of magnitudes 4 Newton, 10 Newton and 7 Newton act along AB, AD and CA respectively. Their directions are in the order of the letters, and they say find the magnitude of the resultant force. So like I said, such questions are easily done by making a sketch. So we are going to first make a sketch of a square ABCD. So that is the square ABCD. Now next is to put the forces which were given. Remember they told us the direction of the forces are in the order of the letters. So that means that 4 newtons corresponds to the AB. So we shall come at AB and put there the 4 newtons. Next is 10 newtons. 10 newtons corresponds to AD. So we shall come at AD and put there the 10 newtons. The next is CA, so shall come at CA. The corresponding force is 7 newtons, so shall come at CA and put there the 7 newton force. Because it's a square, this angle will be 45 degrees. So now that we have put all the forces, next is to get the magnitude of the resultant force. For you to get the magnitude, you have to first resolve both horizontally and vertically. So when I resolve horizontally and vertically, I'll come up with those components. So this, for example, 4 is entirely horizontal, that's why you see 0, 4 here horizontally and 0 vertically. Then 10 is entirely vertical, that's why you see 0 on the horizontal component and 10 in the vertical. Then when it comes to 7, 7 has a horizontal component going to the left, meaning it will be negative 7 cos 45 degrees. Then the vertical component goes downwards, meaning it will also be negative 7 sine 45 degrees. Now when we add 4 plus 0 plus negative 7 cos 45 degrees, we shall come up with negative 0.9497. And when we add 0 to 10, 0 plus 10 plus negative 7 sine 45 degrees, we shall come up with positive 5.0503 newtons. But remember they want the magnitude, so shall come and say that the magnitude will be equal to square root of negative 0.49497 squared plus 5.0503 squared. And when I use a calculator, I'll come up with my magnitude as 5.139 newtons. So basically that's what they wanted, and now let's see how much can be awarded. So the first mark is for you to resolve horizontally, so getting this 4, 0 and this will give you that 1 mark, and the second mark is for resolve vertically, so this and this will give you that second mark. Now the third mark is for the output, so adding the horizontal to give you this and also adding the vertical to give you this will get yourself that third mark. Now the fourth mark is for substitute in the formula for magnitude, and A1 is for the final answer, which is 5.139 newtons. So basically that's how the 5 marks could come about. So now we shall go to question 3, and question 3 came from UNEB 2013 question 6 of paper 2, and says that forces of 7 Newton and 4 Newton act away from a common point. Note that word, away from a common point, and make an angle of theta degrees with each other. Note that word, with each other. Given that the magnitude of their resultant is 10.75, find Roman 1 the value of theta, Roman 2 the direction of the resultant. So like I said, we have to first make a sketch of what is given. You have to know that the forces are 7 and 4 newtons, and they're both acting away from a common point, and the angle between them is theta degrees. So let's first show that on a diagram. So I think you can see this is 4 Newton, this is 7 Newton, and the angle between them is theta, and they're both acting away from a common point. Now they told us that the magnitude of the resultant is 10.75 newtons, and they want you to find the value of theta. So since there are two forces and acting away from each other, we can use the parallelogram rule to get to show the resultant. So the parallelogram rule says that you have to bring this force here and this one here to form a parallelogram, and after that, when you join from here to here, you'll be able to get your resultant. I think we realize that this is theta, this is also theta, meaning this is parallel to this, and for since these are angles on a straight line, this angle will be 180 minus theta degrees. Now that you have completed our parallelogram, next is to show the resultant. Resultant is shown by drawing a line from here to here. So let's do that. So that is the resultant. The magnitude is 10.75 and the direction is alpha here. Now the question said, find the value of theta. First thing, they want you to find the value of this theta. What we are going to do, we are going to use cosine rule, since we know this, and this angle. So we shall come and say that by cosine rule, 10.75 squared is equal to 4 squared plus 7 squared minus 2 times 4 times 7 times cos this angle, which is 180 minus theta. Now when I simplify, I'll be able to come up with my theta as 25.46 degrees. And think that's what they wanted in part A. Now we shall go to part B, where they want the direction of the resultant. So the direction is this alpha, so you have to look for hope of getting that alpha. So you shall come and say that by sine rule, sine alpha over 7 will be equal to sine 154.54. Now this 154.54 is this angle, which is this, and is corresponding to the resultant, which is 10.75. So we shall come and say sine 154.54 over 10.75, and when we make alpha the subject, we shall come up with our alpha being equal to 16.26 degrees. So basically that's what they wanted, and now let's see how much can be awarded. So yeah, this is just a conclusion. You can conclude that the resultant force is acting in the direction 16.26 degrees to the 4 Newton force, or you can say 9.2 degrees to the 7 Newton force. So the first mark is for the first diagram, drawing it correctly with a ruler. That's when you can get that first mark, which is B1. The second mark is M1. It is got by substituting in the cosine rule. And the third mark is A1, which is getting the required angle or the value of theta. And then this for part B, M1 is for substituting in sine rule, and A1 is for the correct direction. So basically that's how the 5 marks could come about. So now we shall go to question 4, and question 4 came from UNEB 2003 paper 2 question 3, and says that ABCD is a square of sides A, forces of magnitude 2 Newton, 1 Newton, root 2 Newton and 4 Newton act along AB, BC, AC and DA respectively. The directions are in the order of the letters of the letters. So know that word. Then here we have say BC is the horizontal. So know that word. It is very important to know which one is horizontal. So BC is horizontal. Then they say find the magnitude and direction of the resultant force. I think you can see previously we have been getting only the magnitude, but now they want magnitude and direction. So like I said, the first thing to do is to make a sketch of the square. So let's come here. Now this is the sketch of the square. Remember they told us that BC is horizontal and the labeling has to be done in an anti-clockwise direction. So if this is B, this is C, it means this will be D and this will be A. Now that we have made a sketch of the square, we have to feed in the forces. So they told us the direction of the forces are in the order of the letters, implying the 2 Newton force corresponds to is in the direction A, B. So we shall come on AB and draw our 2 Newton force. Next is 1 Newton force is in the direction of BC. So we shall come on at BC and we draw the 1 Newton force. Then we shall go to root 2 Newton. Root 2 Newton is in the direction of AC. So we shall come at AC and put our root 2 Newton force. Since it's a square, this angle is 45. And lastly, the 4 Newton force is in the direction DA. So we shall come at DA and put our 4 Newton force. So basically those are the forces which they were given, and now we have to get the direction and magnitude of the resultant force. For you to get the direction and magnitude, you have to resolve vertically and horizontally first. So we shall come and resolve vertically and horizontally to come up with our horizontal component as -2 and vertical component as -3 for the resultant. Therefore the magnitude will be -2 squared plus -3 squared, everything under root, and we shall come up with 3.6056 newtons. So this is the magnitude, but they also want the direction. So the direction will come, we'll have to first draw a right angle triangle. For example, this is the horizontal component, it is negative, meaning it is going to the left. That's why you see here 2 Newton force is going to the left. I think we also realize we are not putting a negative on this sketch because the negative was to show us the direction, is it to the left or to the right. Now this negative shows it's going to the left. When you got the horizontal component, vertical component, the negative shows that it is going downwards. So where this 2 Newton force stops, we are going to add on a vertical component which is going downwards, as you see here. I think we realize that we are not putting a negative on this because the negative was to show us whether it's going downwards or upwards. Now what we are going to do, we shall draw a line from here to from the start to the end that will show, that line will be able to show our resultant. So let's do it. So this is our resultant force, this is the magnitude, and the direction is theta. Since they want the direction, you have to get this value of theta, and the good thing is that this is a right angle triangle. So shall come and say that tan theta is equal to 3/2, giving us theta as 56.3099 degrees. So now that you have got the direction, you can come and conclude that the magnitude of the resultant force is root 13 newtons acting in the direction 56.3099 degrees below the negative horizontal, or you can say with BC downwards. So any of the two is okay. I think that's what they wanted in this question. Now let's see how marks can be awarded. So here M1 is for resolving horizontally, so this and this and this, that is our M1. Then another M1 is for resolving vertically, so this and this, that is our M1 again, second mark. Then the third mark is for substituting this output into this. Then this A1 is for this result magnitude, which is 3.6056 newtons. Then the B1 is for the correct direction. So this conclusion, that's why you get your B1. So basically that's how the 5 marks could come about. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of questions and on projectile motion, and this topic is still under mechanics and is suitable for both students in senior 5 and senior 6. So that brings us the end of this video. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you haven't yet subscribed, please click on the subscribe button below this video so that when the next video with the solutions has been uploaded, you'll be updated. Otherwise, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, such that we all benefit as a family.